All right, let's talk about the internet. It's this thing that has completely woven itself into our lives, right? We use it for literally everything, from ordering pizza to running global businesses. But what's actually happening in that split second when you click a link? Well, today we're going to pull back that curtain and see how it all really works. I mean, think about it. You're using the internet right now to watch this. But if someone asked you to explain how this video traveled from a server maybe thousands of miles away all the way to your screen, could you? It's a tough question, but that's exactly what we're going to break down right now. So to get started, let's just zoom all the way out. First things first, the internet isn't some magical cloud floating in the sky. It's real. It's a massive physical network of computers and cables and routers that stretches across the entire planet. And when I say massive, I am not kidding. We are talking about billions of devices, everything from the smartphone in your pocket to your laptop to these gigantic data centers, all humming away, all connected and chatting with each other constantly. If you really boil it all down, the incredible power of the internet kind of rests on three main pillars. First, there's the connectivity. It's just on a scale we've never seen before. Then, you've got this bottomless pit of information. Pretty much all of human knowledge is just a search away. And when you put those two together, well, you get what we have now, a complete transformation of how we live, work, and connect with each other. So, how does a message get from my computer to yours? How does all that communication actually happen? It sounds super technical, and it can be, but the core idea is surprisingly simple. The best way to think about it is like a giant, incredibly efficient global postal service. Seriously, every single thing you do online, sending an email, loading a web page, streaming a movie, is basically you sending and receiving little digital letters. We call them data packets. And this whole system runs on a very strict set of rules to make sure every single one of those packets gets exactly where it needs to go. In that official rulebook, the language that everything on the internet speaks is called TCP/IP. This is the big one. It doesn't matter what kind of device you have, a Mac, a Windows PC, an iPhone, they all use TCP/IP to talk to each other. It's the universal standard that makes it all possible. Now here's the really clever part. TCP and IP work together like a perfect team. Think of TCP as the really organized postmaster in the mailroom. It takes your message, carefully chops it up into numbered packets, and then at the other end, it makes sure every single packet arrived and puts them all back together in the right order. Then you have IP, the mail carrier. IP's only job is to look at the address on each packet and figure out the fastest, most efficient route to get it there. But how does that digital mail carrier know where to deliver the mail? Well, that's where the IP address comes in. Every single device connected to the internet, your phone, your laptop, your smart TV, gets a unique IP address. It's literally just like a street address for your house. It's a specific set of numbers that tells the internet, hey, deliver the packets right here. Okay, but let's be honest, none of us are memorizing long strings of numbers to get to our favorite websites, right? We use names like example.com. That's possible because of something called the DNS, or the domain name system. You can just think of it as the internet's giant public address book. Its one and only job is to look up the name you type and find the correct IP address number for it. And this whole lookup process happens in the blink of an eye. You type a website name, your computer shoots a message to a DNS server saying, hey, what's the number for this site? The DNS server finds it in its massive list, sends that number back to your browser, and boom, your browser can now connect to the website. It's simple, elegant, and unbelievably fast. Okay, so that's the massive global system. But how do we, actually plug into it? How do we get from our couch onto this information superhighway? Let's talk about the different on-ramps. So for most of us at home or in the office, we're using a broadband connection. It's fast, it's stable, it gets the job done. But if you're doing something like competitive gaming or downloading huge files, nothing, and I mean nothing, beats plugging in an old-school LAN cable for maximum speed and stability. And of course, when you're out and about, USB tethering lets you use your phone's connection to get your laptop online. It's all just a trade-off between speed, stability, and convenience. This brings up something that actually trips a lot of people up, the difference between Wi-Fi and a hotspot. It's pretty simple, actually. Wi-Fi is the technology. It's the radio waves that your devices use to talk to each other without cables. A hotspot is the place or the device, like the router at your coffee shop or even your phone, that's creating that Wi-Fi signal for you to connect to. All right, so we're online, we're connected, but there's one last and honestly, probably the most crucial piece of the puzzle we have to talk about: making sure all our information, all our data stays safe. I mean, just think about it. Every time you log into your bank, type a password, or buy something with a credit card, you're sending incredibly sensitive information out over the internet. So the big question is, how can you be sure that nobody is listening in? Well, the original version of the web used a protocol called HTTP. The huge problem with it is that it sends all your data in plain text. That means it's like writing your deepest, darkest secrets on the back of a postcard and dropping it in the mail. Anybody who happens to grab it along the way can read everything. Not good. Thankfully, the solution is something called HTTPS. That S on the end is the important part. It stands for secure. And what it does is it encrypts your data. It basically takes that postcard and seals it inside a locked, tamper-proof envelope that can only be opened by the person it's addressed to. It's a total game changer for online safety. So here is the number one thing I want you to take away from all this. From now on, always look for the little padlock icon up in your browser's address bar. That padlock is your signal. It tells you that you're on a secure HTTPS connection and that whatever you send is encrypted and safe from prying eyes. If you don't see that lock, be very, very careful about what information you share. And that really brings us full circle. The entire reason the internet even works is because it was built on these open, universal standards like TCP/IP and HTTPS that anyone can use for free. It created this level playing field for communication and innovation. And as we look to the future, the big question we have to ask ourselves is, will it stay that way? Will that fundamental openness continue to be the heart of our interconnected world?